Thank you. As Bob mentioned, I'm a mining engineer. The work I do is designing open pit mines, and my topic is very similar to what Adrian talked about just before lunch. It's about low-grade deposit and how to make the most benefit out of this, deposit. So the outline of my work is my presentation is just few. First, I start with explaining the situation, the trend in the market about deposit we are dealing with nowadays, and then after that, I'm going to have a short introduction about cut-off grade. That's maybe boring for mining engineers in this room. It's just I want to refresh your mind about cut-off grade. Definition of cut-off grade and different variations of cut-off grade, which is important and sometimes confusing. So I want to explain that part as an introduction to what I want to explain as the main goal of my presentation. I want to talk about cut-off, cut-over grade analysis, and I explained that one with giving you an example of gold mining, how we can use this type of analysis to increase or boost the NPV IRR of projects. About the trend, I think my friends, they explained about that one before lunch, about that nowadays the market is really not a very steady market, is up and down, but what we can really see as a trend is that as we go forward, there is not much really easy mining left in the market. All the deposits that we see, they are really challenging deposits. They are either low grade or in the very challenging area. The access is not easy and many things like that. I want to focus on the low-grade characteristics of today's deposits. For copper, gold, metal, most of the metals, what we see is that deposits are low-grade. This graph shows from 1950 to 2010, as you see the grade going down and down. Part of this trend is because of the new technology we have, because we can really process lower-grade material. And part of that is because of the new equipment we have, the operating cost has gone down, and so the prices are up, so we can't really afford to mine lower grade deposit. That's part of it, is that one. But another part is that really we don't find real high grade deposit anymore. Most of the deposits are really low grade. If you want to mine it, you have to blend it and make benefit of economy of scale, and that is low-grade deposit. And this is another graph that actually we produced here in SRK. I just did a quick search of newly reported published reserves, and as you can see from 2005 to 2014, the average grade, fit grade for majority of the deposit, the projects we see on CEDAR is going down and down. And so that's a characteristic of what we are seeing in the market. And so what to do with this one, with low-grade deposit? That's the subject of my work. As being a mining engineer doing the design, one of the things I do, I collect information from these different disciplines, geologists, metallurgists, and economists, and put all those information, build a mine model that it simulates the entire mine life. And at the end, I can really see the economic benefit of the project. But that gives me the benefit of working at different parameters that positively and negatively affects the outcome, economic outcome of the project. And I'm focusing on one of them, which is different type of processing method that we can implement for different deposits to maximize the benefit. So that was basically my introduction to strategy mine planning. What we do, we put all those input parameters together and do a quick simulation of the entire life of mine, and then we do a quick economic analysis and we see how it looks. And the good thing about the strategic mine planning is that, before you go to depth of analysis and, collecting data, you can look at the sensitivity by setting up different scenarios, and look at different scenarios, how it behaves, in regard to your deposit. So after that introduction, I would like to give you another introduction, the second introduction about cutoff grade, and refresh your mind about cutoff grade. What is the cutoff grade? Cutoff grade is a grade that we do something below and we do something else above. Cutoff grade is sometimes confusing for many people that read reports. We have many different cutoffs. We use cutoffs in different contexts. It's important to know what type of cutoff we are using. And for example, resource modeling, usually in the report we see the cutoff. That cutoff is basically a threshold number. It doesn't have anything to do with the economy. It just, you sort out your deposit, and then you choose one that is closer to the economic cutoff, but it's not really an economic cutoff. So it's important to know the cutoff that we use, the way we define it, it really separates two different course of actions. That's simple. For mining, when you mine a ton of ore, the most important decision that you want to do about that ton of ore is whether sending it to waste or dump or to mill. And that's the most important cutoff that we usually talk about. I'm going to talk about two different type of cutoff. Mining cutoff grade is one. Mining cutoff grade is the grade if you include all the costs that includes not only the mill G&A but also even mining. So let's imagine that you're walking on a rock and is not mined yet, and you want to make decision, does it have any value? Does it have enough value to be drilled, blasted, and loaded and hauled and milled? If that ore has enough value that can pay off all those costs, then that's the, that you're gonna mill it, and that's the mining cutoff. The minimum grade that it has that rock, the rock that you're walking on it doesn't need any stripping. So it doesn't include the stripping cost, but it includes the mining cost, milling, G&A, and the rest. That's the mining cutoff. And then we have milling cutoff. Milling cutoff is the cutoff that you calculate using all the processing costs and the general administration costs. That's the milling cutoff. Milling cutoff is the lowest cutoff that we use in mine design, and we are talking about. So we don't have anything below milling cutoff. Milling cutoff or marginal cutoff, sometimes people talking about. That's the lowest cutoff ever. So it's important to know that which cutoff we always talk, and in this graph you can see mining cutoff is higher, milling cutoff is lower, and that's because mining cutoff basically pays up for the mining cost, whereas milling cutoff does not do it. Milling cutoff is important for us for design, for mine design plus for scheduling, because whatever in open pit, whatever you mine is available now to make decision about whether call it ore or waste, because you already spent the money for mining it. Now is a sunk cost. Now you don't need to include that one. If it pays you even 10 cents, if you send it to the mill and mill has enough capacity, then why not? Because you already spent that money for mining, and if you send it to mill, you're gonna recover 10 cents, so you do it. So that's the logic behind it, that we use milling cutoff for most of the designs. So from now on, when I talk about cutoff, I mean milling cutoff, most of the times. One of the things I would like to mention about cutoff is that most of people, especially geologists, when I talk to, they think that cutoff is an input for the design, whereas this is really wrong. Cutoff is an output of the parameters you put into the system. It's not really input that you make decision and put it there. No, based on the parameters that you use, then cutoff is calculated. Yeah? So cutoff is not really an input to the system, but a result of the parameters you use. Cutoff is really, there are lots of parameters that influence the cutoff. The most important one is the price. Price is the most powerful factor in mine design, and that affects the cutoff. Nowadays, you look about 3 weeks ago, the copper price was 3, now it's 2.5. It's really not easy to pick a price in this market and based on that doing the design. But it's important to know that this has a big effect on your mine design. We are talking about, let's say a billion ton of ore versus 700,000 ton of ore. If you choose $3 or $2.50 per pound copper. Offsite costs are another one. Talking about the mine design, cutoff grade in particular, you have to do your assignment very well, research about the offsite cost. We call it sometimes selling cost. For greenfield projects, this is the area that is not really clear because we don't know much about the product we are producing, the system that we're going to put in place, and but they are important. Sometimes they are about 35–40% of the total cost, and if we exclude that one, that may, not excluding, if we don't really see it well, don't calculate that well, it may affect your design. For example, for a zinc, I just recently did it, for a zinc project, the offsite cost, it can be about 50% of the total cost, or very close to the 50% of the offsite cost. Because, for example, the payable for zinc is about 85%, so 15% you are losing just there. And shipping, smelting, refining costs, penalties are other things. And mill recovery is other things, mill operating costs, general administration costs, dilutions, all of them are important. I'm gonna now go and talk a little bit about different type of cutoff and different factors with more detail. Very simple formula for calculating cutoff is here, revenue on one side, operating costs on the other side. How you calculate the revenue is can become really complicated because it's not just the price, it's the recovery, it's the all the offsite costs and so on. And operating cost is not again simple. Is processing cost is very simple, but then G&A it can become complicated. What part of the cost you should include in G&A and what part you should exclude. So. But that's as easy as this formula. Picking the numbers to put in this formula can become challenging. If we use that formula and bring it in a graph, you can see this is the graph for the cutoff, and that's the cost of processing. And as the grade increases, the value of your rock increases, and if it passes the total cost of processing plus G&A, then you have positive value. That means that you're going to the positive territory, and that's you get some value out of your system, and you call that one cutoff grade. Means after that you send it to the mill. And of course, cutoff grade is sensitive to a few things I mentioned before, but here obviously it's sensitive to the recovery, to the price. If price increases, obviously this goes, it gets steeper, and then cutoff goes lower. And if you lose on recovery or prices, you have to mill higher grade material to basically make better revenue to pay off all those costs. Variable recovery, some challenges. We used here straight lines, but all we know that this is not a straight line. This is other challenge that we may have in the calculation of cutoff. Recovery obviously is not really a single number. By increasing the grade, the recovery gets always better. Low-grade material, they have lower recovery. So that affects the cutoff. So what I mean is that in a deposit that you are designing in one block, cutoff may be completely different in one zone than the other zone. It depends on really the average grade that you get from that. Some other small things like waste treatment costs or anything, if you want to deal with low-grade material, spend money more than what you spend on a regular waste, on a particular type of waste. For example, they generate acid and you have to treat it. Then if those marginal grades, the cost that you pay for that marginal grade is more than what the loss that if you send it to the mill, in those type of the cases, you may send that marginal grade to the mill. Because if you send it to the mill, for example, you lose 5 cents, but if you send it to the, to the waste dump, you have to spend 10, 20 cents to treat it. So what do? If you have enough capacity, you send it to the mill, although you know that you're going to lose 5 cents, but it's better for overall economy of the project. So this is another complications of cutoff grade. Rehabilitation cost is, graphically we can show it here, yeah, that's the cost. So that basically because of that, you increase, reduce your cutoff grade. What about dilution? Many people ignore dilution. Dilution is a big, big part of the cutoff grade. Dilution is a direct cost to the processing. If you have 10% dilution, that means that if you're sending 100 ton of ore to the mill, 10 ton of that 100 ton is waste. And if your lab told you that your processing cost is $10 per ton processed, now you are spending lots of reagents on 10 ton of purely waste. So the amount of dilution is a direct processing cost, and that really increases the cutoff by a very completely direct cost. Always keep that in your mind. In most of the cases, we don't have only one product. We have many products. Very simple case for the gold mine, you have gold and plus some credit for silver. For this type of cases, how do you calculate cutoff? So cutoff for these cases is not as simple as a single line. It's wrong if you choose a cutoff only for gold because you have some credit for silver. And if you do your calculation independently and graph it, you can see that you can mine lower than normal cutoff grade for most of the blocks. And the reason is because for this example, if you go to 0.80 gram per ton gold, because it's below cutoff grade, but because you get some credit from your silver, then basically it pays you more money and you can really mill it. It pays off all those extra costs. So another complication again for stockpile for cutoff grade is that by knowing all those cutoff grade, when we go to the to scheduling and mine design, it's not like that. That whatever that is below cutoff, it goes to the waste, and if it's above cutoff, it goes to the mill. There are other complications. For example, because of the changes we see in the price, you may want to stockpile some of the marginal grades just in case in future to use it. Sometimes your mill has extra capacity or not extra capacity, I'm sorry, is a small mill and cannot handle the ore that you produce in mine. In that case, you have to be selective and you send to the mill the better grades. And so the lower grade that still is above cutoff, you stockpile that. So stockpiling policy, it goes hands on hands with cut-off grade analysis, and sometimes if you spend more money on your mining capacity to speed up the production of the mining for the same mill, economically is better because you mine high grade faster, cash more money in advance, and basically you improve the NPV. So that's another thing that you should. Thank you. Yeah. Another thing. That's my main. Now introduction is finished. 5 minutes. Multiple processing method. This is what I wanted to say. Low grade material. We have lots of low grade deposit. How to deal with that one? The big challenge for low-grade deposits are that if we use a single type of processing method, usually what happens is that we lose a big value, chunk of value from our deposit. If you deposit, is let's say a gold deposit, a CIL, what you do, because of CIL is an expensive method, and the cutoff is huge, and the marginal grades, you're going to send it to the waste. Why not to have another processing method to help it? What is the cut over grade? Cut over grade is similar to cutoff grade, but is a grade that if you have a multi-processing method, you switch from one method to another method. In this graph, it's very simple. Look at this. You have a heap leach, because heap leach is a cheaper recovery and a lower recovery and cheaper processing method. That's is not that steep line, and your cutoff is lower than the mill or CIL. So the place that these two lines they intersect, that's the cutover. What does it mean is that you should mine from here to here using heap leach, and after that one mill. If you have only mill, you mine from here above to CIL, and what you lose is the cutoff of mill and below. That's the deposit that you're going to lose. Let's have a quick example of a gold mine. This is a big deposit, and as you see, there are 3 different options for processing it. You can have one of them or all of them. You have a CIL, which is expensive one, but it has much better recovery, and you have a heap leach. Heap leach can go in 2 different circuits. One big run of mine, it goes to directly to the heap leach. Another one is that you crush it and then send it. The numbers that I use in this analysis is here. So for the run of mine, heap leach is $7.10, 7.10, and recovery is 48. For the heap leach 2, which means after crushing is 9.25 and 57%. So we spend more money, but the recovery is better. For CIL, the cost is much higher, but the recovery is much better. So if you use these numbers, you can do the analysis. The questions are, what processing method is the most economic method? And if you decide to use heap leach method, which one you want to use? And for heap leach method, if crushing is better or without crushing. So basically this analysis helps you to pick different systems for your processing. And then let me show you the thing. So I did the analysis here for the CIL, the green one, for the crush heap leach, the red, and the blue here. So what it suggests is that run of mine, it can go from 0.44 and above, you can send it to heap leach, up to 0.7. From 0.7 above, it's better to crush it and then send it to the heap leach, and then after 0.88, it's better to send it to CIL. So that's the analysis is good. So after this, then you can make decision. To make decision, you need 2 more pieces of information. I'm not just covering that part. One is that you need to analyze or study your tonnage grade curve to see in different grade brackets how many tonnage you have in your deposit, and plus in each system what is the capital involved with to install that system. And thank you so much. Sorry that it took long.